Hey, third time's a charm. K1GMM Steve here. Going through the SDR2DX TX audio setup. And I'm going to race through this. I'm going to try and do this a third time because I screwed up and I had the windows over each other so you guys couldn't see as I'm sure you saw. I hate to waste anybody's time, and I'm getting pretty bent out of shape because it's a lot of my time wasted. A lot. Production value, not that great right now. Here we go. First thing you want to do is this is the V2 software by Expert. This is strictly in relation to the Sun SDR2DX. Depending on how you bring your mic in, your mic is selected right here. I bring my mic in analog through the front, through a Ohio cable, comes out of a direct box, and the rack dumps into the direct box and then passes through to the Ohio 3-pin XLR cable. The cable is the same cable that the Yaesu 857D uses. So you can use that cable. Works great. All right. I do have the mic AGC enabled. I had a question regarding that on one of the streams. I'm going to show you how I have that set up. So if you come over here to Processor, PROC, click on this, go up to the AGC. I'm going to just leave this screen here so you can look at it and you can try these settings. Leave it for a moment. And what you can do is you can freeze. I'm going to do this so you can freeze the YouTube video and you can go through the settings to set it up. Whether it works for you, can't guarantee it. This is what I do. This is how I set it up. I was asked, so I'm going to show you. I don't even know if it's the right way. Take it for what it's worth. If it helps, cool. If it doesn't, busted. Down to the compressor. Actually, I do run the DC block. I believe that's set to default. I don't know if that's worth running. I don't even know what the stupid thing does. It was on by default, and I didn't really hear any difference, so I ran with it. Compressor. I run a 1.3 to 1 compression. You can look at the parameters here. This is a very mild compression. And of course you can change, and it is running in hard, type hard. And I find this works well. The compression on the Sun is very, very good. It doesn't tend to overmodulate like a conventional superhead does. Onto the limiter. Here's the limiter. I do run this, and I'll explain why in a moment. Let's take a look at that. Okay. Now, and that's those are the only things I have running in the Sun. I'm going to explain the limiter right now. So the reason why I use a limiter is let me kick the monitor out. So if I stomp down the pedal, let's get rid of this now. If I stomp down the pedal, you'll see the ALC right here. I want that up around 0 dB. If it goes above 0 dB, like really crushes it, you'll end up with a lot of IMD. However, it will drive the amp. See that white line? It's going over 0 a little bit, so it's not quite pulling it under control. I may have to reduce the gain on the rack coming into the radio. So if you go above 0 dB, if you're running a linear amplifier, it'll drive it much, much harder. However, the IMD will increase. You won't get any distortion on it, on your audio, but the IMD may increase. So try to keep that around 0 if you can. All right. All right. What else? Oh, there was one other thing I wanted to show you, explain to you, the equalizer. So let's say if you're going to use this, right? Use this equalizer. This is a great tool. The onboard processing in the Sun is superb. So even if you didn't have a rack or you weren't running a DAW and you brought a mic direct into the front, maybe you had a little preamp and you fed the audio in, you wanted to use the onboard processing. It's really good. Now this EQ is no slouch. It's not a huge EQ, but it's incredibly powerful. So let's say you take this slider right here. This increases and decreases it boosts or cuts the frequency that this slider is set to. So you'll see right here, this slider right here is set to 60 hertz, right? Now you can adjust that frequency by this knob right here, this knob. If you left click it and you pull it up, it'll increase the frequency, right? So what you want to do is you want to set your frequency. Now the cool thing about this EQ is it's like a paragraph. It's like a hybrid parametric graphical EQ, right? So it's more of a parametric, really. So these bottom white virtual knobs here is the Q, which means on a regular graphical EQ, even though it's set at 60 hertz, that's the center frequency of that slider. When you boost or cut this, it will boost or cut frequencies outside on either side of that 60 hertz as well. So let's say you had a harmonic issue, right? And you needed to remove a harmonic. Well, you could do that with this EQ by taking this knob right here, below the number, left click and pull down, it will expand the Q, right? So just to demonstrate this, if you take this slider now, so the Q is very broad. So it's affecting a lot of frequencies on either side of this. So if you cut it, see how that line, I mean, it's affecting a lot of frequencies on either side of that frequency, 60 hertz. So let's say you wanted to target a specific frequency, boost or cut. You can increase the Q. So I brought that up to 22.6. So now watch over here what happens when I boost or cut. Bring this down. See that? Very sharp. Very sharp. So I just wanted to explain the EQ for you. All right, enough of that. Very powerful. Very cool. Anyways. Next thing I wanted to explain is this is kind of an important aspect to SDRs, and a lot of people who are new to it don't realize this, especially this particular SDR. So if you right click and you drag your filter out, you will see, so let's put it at 3 kilohertz, right? So I'm at 3 kilohertz. By default, the filter's probably going to be sitting around here somewhere. Maybe around, if you move your cursor and you see these two white lines light up within that filter window, that filter, receive filter, is set at 3 kilohertz to about 100 hertz, 99 hertz, right? So keep in mind, if you're listening to someone and they're pushing audio below 100 hertz, you won't hear it if your filter is set that way. Remember, on lower sideband, these are the low frequencies in here. These are the high frequencies. Even though it says low, even though up there, up here, it says low 3,000, high 99. Well, it's reversed on lower side. So your low frequencies are here. So by default, most likely that filter will be set to like 100 hertz when you first light it up. I don't know. I can't remember. What I do is I always grab this line. If I'm listening to somebody running ESSB audio or Voodoo audio, I always move this filter, this low side, which is technically the high side on lower sideband, but it's the lower frequencies. I make sure that's pulled right out to 0, just like that. You can left click, hold it, and drag it out. So now it's 0 to 3 kilohertz, right? Not necessary if you're working DX, and you may not want that, because also with that comes, if people are encroaching in the passband and their splatter, it will open that filter width up so that the splatter will be more noticeable. So that's the drawback to that, okay? Anyways, this isn't about the RX side, but I wanted to explain this so you understand how to set your audio up depending on what you're doing, what your goal is, what mode you're operating in. In other words, do you want to run just regular DX audio, smooth, flat DX audio? Do you want enhanced audio, a little bit more bottom end and a very transparent top? Do you want ESSB audio? Do you want Voodoo audio? So understanding how people are listening to it is very important, and I'll show you why. If you're talking to people you talk to all the time and you know that they're listening on an SDR or an opened up superhead or an SDR dongle, and you talk to them all the time, and you know that they have a good system for listening, then your audio will be appreciated. But more often than not, if you're just generally calling CQ, probably not worth running ESSB audio, to be honest with you, because most likely people will come back and they're running just a conventional superhead, let's say a 7300, which is only going to hear like 100 hertz to 3.6 kilohertz. Now we'll hear to 3.6, right? But it depends on where their filters are set. So here we go. This is how you develop the energy so that it's kind of like a Swiss Army knife. Your audio becomes like a Swiss Army knife. People of all running all different types of systems can copy you. You're legible, you're articulate, and yet you sound really good on pretty much any system. And on someone who's listening wide on a big system like an SDR, and they have like what I have, reference monitors with a Polk Audio subwoofer or something like that, they will appreciate it. But my approach is to make sure that people understand what you're saying, you're copyable, you're clean all the time. So there's a few things you can do to make that happen. So now that we covered the stuff on the sun, I believe that's pretty much it. So what we're going to do is we're going to set up on a 3 kilohertz profile. All right, let's go to lower sideband. Even though I'm on a dummy load, it doesn't matter. And we will go to 3 kilohertz, and we're going to crack this open right here. See how it's at 70 hertz? I'm going to pull that out to 0 hertz because we are going to listen to it through the radio. Put my drive at 0. One quick mention of the profiles. So if this applies to all the different profiles, all right? Before you start building the profile, it helps to have the general settings set up the way you want them. All right, so let me do this. The way, you know, your drive level up here for your amplifier, blah, blah, blah. There is a way to fix that if you screw that up. So, first thing you want to do is go into Options, Device, TX, and you'll notice this 3 kilohertz profile. I call it an ESSB profile, but it's really enhanced sideband. It's not extended. 3 kilohertz is not extended. It's more enhanced. So I have the low set to 20 hertz, the high set to 3 kilohertz. This is where you set your sideband audio bandwidth, frequency spectrum width. Okay, and so you set that up, make sure that's good. And you can do that like 20 hertz for your 20 hertz to 3600 hertz, 20 hertz to 4 kilohertz, and you can save that as 3 kilohertz profile, 3.6 kilohertz profile, 4, you get it, right? Okay. So up here, click this. I found that the Expert software hates special characters when you're trying to save a profile. As I don't know what's wrong with it, but it wants just numbers and letters. So what I do is I put in, so for this I put 3 ESSB, so you could put 3 whatever to identify it, click add, boom, that's done. Now, once you get finished tweaking, right, this is important because you don't want to go to work on the rack or the external audio gear before you have your profile set up. Because if you listen to it through the monitor, it's going to be all screwed up. It's not going to be right. So make sure you do the profile first. So let's say you get all of the stuff set and you save the profile and you forget something. You go, oh crap, I got to go in and I got to delete that. Well, you don't have to delete it. You just make sure it's on the profile that you're working on, 3ESB. Go down here to update and then choose 3ESSB. Click on it and it'll ask you if you really want to update it. Click yes and boom, it'll update all your settings. Done. Moving on. Okay, I'm going to expand this out. Okay, we're moving on to the external gear. So this is how I approach doing this. So the first thing is up here, you want to right click on this meter on the sun, go to TX and select mic meter. And you're going to have to watch that. And also this is the gain, the mic gain. So you may have to fart with the gain a little bit. And the goal, let me punch the key and watch this meter. The goal is to make sure you're up around 0 dB. So 0 dB, and that looks pretty good. So we'll go with that. Okay, so what I'm going to do is I'm going to reel this in a little bit so it's actually more interesting the narrow the filter is. So I'll show you what I'm going to do. So if you come over here to the rack, remember signal flow, we went over this. It's like water through pipes. It has a start point and an end point. Beginning, end, start, finish. So what I do, tell you how I approach it. This rack is a 2-channel rack except for the end, which is the reverb. So I have 2 different microphones. So what I do, I'm on the headset right now. This is an Audio-Technica Pro 8 HE. It's a piece of crap. It's very, very sharp, which I'm sure you can tell, but it actually is a great headset for what I'm doing. So for a 3 kilohertz profile up to like a 3.3, 3.6, even 4, it's not bad on 4, but it's really not what I would prefer to use on 4. How I approach this is it's all about the energy. So how do I generate an audio profile that will cover the bases from 3 kilohertz to 4 kilohertz wide? There is a way to do this. So let me I'll demo it for you really quick. This bottom EQ right here is for, make sure I'm not clipping. I am not clipping. This bottom EQ is for the headset I'm on. Okay, so let me open the gate a little bit. I think that's a little better. And you may hear the gate kind of clicking in and out. I haven't really, I redid this and whatever. So set your preamp up, get your settings in your preamp, which then flows into the EQ. Check your gain level, make sure you're not clipping. Every time you make a change in your audio chain, the next device after that, you're going to have to reset the gain because the gain will change, whether you're boosting or cutting or doing whatever. Most likely it will change. Okay, so how I have this set up is I have it set up so that it's got great audio going to, let's say, I'm going to bring this up a little bit, the 60 hertz. Just put a bump in there, 50 and 60 hertz. And this will give me a nice warm bottom end with tremendous clarity on the top end. All right, so set your audio up to how you think it sounds good. But how I would do it, if you have the option to do this, there's 2 options. Set it up on a broader profile first, okay? And how do I explain this? Set it up on a wider profile first, so you have some nice bodacious audio, whatever is to your liking, right? And if you have a way, like the next device down here is the AFX204, so if you have a way to flatten it out with a push of a button, then you can immediately move to a 2.8, 2.9, 3 kilohertz profile and have some real banging audio for DX and working contests. So my system right here, all I have to do is press the process button and I'll bypass the AFX204. So here we go. So here we go. This is basically a very flat, much flatter, still a nice audio for DX. You could sit there and listen to it for a while. It is narrower, doesn't have the big bottom end. But that's basically all I have to do. Now, the other way you could do this, let me kick this back in. So this is with the AFX in. As you can tell, it's got much more top end and a lot more bottom end. All right. Now, on a large diaphragm studio condenser, this becomes Goliath. This microphone's kill box is about 800 hertz to 2 kilohertz. That's the sweet spot. That's the peak in the frequency spectrum on this microphone. And it falls off rapidly from about 500 hertz, 400 hertz, all the way down, going into the bass area. So I have to put a little go-go juice in it to get any bass out of it. Now, the other way to do this is if you have a 2-channel rack, all you have to do is set it up so that this, your 1 channel, split the output of the 1 channel on the output of the preamp and bring it into both sides of the next piece of equipment in the chain, which would be the EQ. And then what you can do is you can just repatch the output. As you can see, both sides are active, and that's because I have a large diaphragm studio condenser in this side. That's plugged into this side of the rack, and it comes into channel 1. My headset's in channel 2. This is the preamp for the headset. So I run 2 different microphones. If you're only running 1 microphone and you have a 2-channel rack, it's a piece of cake. You just split the output, get yourself a 1/4-inch splitter, come into, so you'll have 2 lines coming out of this, come into both sides of your EQ. It comes into both sides of whatever you've got going down the chain. The only thing you will have to do is repatch. You'll have to take the Heil cable. Now, this is in reference to a rack. You'll have to take the Heil cable out of, let's say, this the headset, or let's say your DX channel that's set up for DX, and you'll have to plug the cable into the other side, which the EQ and all the other stuff will be set up for, like ESSB and Voodoo. That's one way to do that. If you're on a DAW, you won't have to do that because you'll have a whole separate profile saved. All you have to do is close that DAW profile and open the ESSB profile or whatever other profile you're going to, and boom, there you go. Of course, that's all fed virtually, passed virtually back and forth from the rig. All right, so that's how all that is working. So I can kick out the EQ, so I can bypass this. I can go to more of a flat DX profile, and I can kick the EQ out just like that. And it becomes just basically communications grade audio, great for DX, and I'll show you the difference. So I'm going to stay on this right now. So when I key the radio and you watch the waveform in this area, right? Let me key it. I'll key it up and you can watch the waveform, and you can see where the energy is. It's still a little heavy in the bottom, right? But what you really want to do is hear it through the monitor on the radio. So I can do that. Stand by and I'll deactivate this audio. Okay, so this is, oh, that is really hot. This is the audio. This is check. Okay, that's a little better. This is the audio through the transceiver. This is actually, I can't, I'm trying to talk, I'm trying to listen to it, and there's so much delay because I have it on an MME driver that it's impossible to listen to and talk at the same time, so I'll just leave it muted on my end. But this is the audio through the radio, so when you monitor it, you can kind of check it. So if you notice the energy, where the energy is, there is plenty of energy in the top end. This is the top end right here. So if I say Sierra, 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 see that peak? That's equal to the bottom end. Sierra, Tango, Victor, Papa, Tennessee, Tennessee. See where the energy is? So from right here going up, that's mid-range and top end in the 3 kilohertz spectrum. That's good. That's what you want to see, because if your signal, stand by, I'm going to mute this. So your signal, if it becomes marginal, let's say there's a lot of QSB or there's some bad QRM, it is still copyable and it's still nice to listen to. So there's a compromise This is how I approach it. There's a compromise that needs to be made. I have made the mistake before of running too much bottom end while working DX. And it does become very annoying. I was talking to a guy yesterday, Nick, and he says, yeah, it's becoming a little tough to listen to. So just be aware of that. You want people, if you got an armchair copy, that's great. But if there's some sharp QSB, pay attention to where your energy is. Because let me key it up again. So if all your energy, and how many people do you see on the radio that have no energy in the top? They got this big, huge bottom that's like booming. It's spiking way, way up. And they're like, there's nothing. Their high end is like way down here. You know what that sounds like. It's like, it looks like that on the pan adapter. That's what it sounds like. No articulation, no nothing. So develop your audio profile to produce some nice energy, and I would say focus on 500 hertz, depending on the microphone and your voice. Now, it depends on your voice. I have a very low voice. So I'm going to actually kick the exciter back in and kick the virtualizer back in. So there's just a hint of reverb. And so what I was saying was, when you develop your audio profile, pay very close attention to how much energy you have in the top and bottom. If you can, get it balanced. Get it balanced. The spectrum where you want to focus on to get that energy is probably around 500 hertz, 400, 500 hertz. It's not muddy, but it increases the presence, the mid-range presence of your voice. And 1.6 kilohertz is the kill box for a good frequency. 800 hertz, beware of that. Boosting, cutting. Cut too much of it, you'll go muddy. Increase too much of it, it'll get hollow sounding. 1.6 kilohertz, 2 kilohertz is pretty garish, but it is where the primary articulation comes from in the human voice, from 800 to 2 kilohertz. That's where it all starts. The silk, the nice part of the top end, doesn't even start until you get to 3.3, 3.5 kilohertz, right? So, and then, if you go back and you look at the EQ here, so I've got a bump around 60, 80 hertz, and I don't want that Goliath, that thunderous bottom end on this microphone. I got another microphone for that. That's the ESSB voodoo stuff. This is like a general coverage, general purpose profile I have. All right, I got a boost around from about 400 hertz to 630, kind of a little boost there. And coming up 800 hertz flat, and then 1.6, I got a pretty good bump. 2 kilohertz, I got a slight bump. 2.5, I got a good bump. 3.15, I got a pretty steep bump. And 4 kilohertz, I got a slight bump. So now on this profile, coming back over to this profile, right? Now keep in mind, same microphone, just with the flip of a button. I can completely change the way this thing sounds. So if I key the radio up, you'll see that the devil's horns have started to show up. So if I check my top end, Sierra, 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 it's almost equal to the low frequencies. That's what I want to see. And it got a little deeper. You can see like a deep dip on the spectrum here. And if I go audio, CQ, K1, GMM, testing, Sierra, Tango, Victor, Kentucky, Tennessee, I want to see that top end on this profile way up here. Now, if I want it bodacious, I want that big. See where that bottom end is? Right there, if I stretch this out. See that bottom end? That is way down there. That's way down in like the 30, 40 hertz range. Probably 40 hertz. That's what I want for that. But, if I kick this out and I go back to see what happens. See how everything kind of flattens out and the mid-range jumped up on me? That's good. That's good. There's a lot of energy. all the way through that spectrum. It's not harsh, it's not garish or anything, but it'll make your audio much more readable, much more copyable in marginal band conditions. And when you're working DX, you're doing contesting, but it's still nice to listen to. Yes, you can tweak it even further if you wanted to. So, yeah, that puts us around the horn. So hopefully I got this right. Don't forget, watch your mic gain. You're going to have to adjust the output drive of the, and I think it's, I don't know if here's an issue. What you're hearing in OBS is not what's coming out through the radio. It's not it may sound a little too sharp coming out of the radio, but the way these radios interpret the audio, it is not the same. So I'll just show you. So this is the raw audio coming out of the rack. All right, and I have a slight dip in the high end in OBS because I need it pretty sharp to get the energy where it needs to be. So let me mute this, and I will turn on the monitor on the Sun, and you can listen to what it sounds like coming through the Sun. Okay, so this is coming through the Sun right now. So this is the audio, and this is the enhanced audio, not the DX audio or the contest audio or whatever you want to call it. This flatter 3 kilohertz audio. So let me drop the key, and I'm going to go to a 4 kilohertz profile. Stand by, and I'll show you what happens. Okay. Test 1, 2, check. Testing. K1 and GG. I can't talk. I can't talk and listen to it at the same time because there's about a quarter-second delay because I'm not on the SEO driver straight to the card, and that's because I wanted to bring this into OBS. So that's the audio, a little hot coming into OBS. So as you can see, you can jump. A very versatile profile. You can jump back and forth. Now, if you wanted to make it a little bit more bodacious in the bottom, I could take the exciter and I can bring up the bottom end. So as you can hear, I got a little bit more bada boom in the bottom end, but you can see the energy, Sierra, it's still not bad. It's not bad. So with a twist of a knob, and you can see that the ALC, the mic gain jumped. It got pegged all the way to the top. See how that's jumping up? That's an example. You may have to reduce the output drive on your rack just to bring that back in line. It's not horrific, you can see, but it's jumping up to a +2 at times, and that's probably a little much. So I brought this back down to pretty much normal. So if you watch the spectrum, Sierra, watch that top end right here, this top end and the bottom end. You kind of want you want some energy up here because as the conditions fade, yeah. Of course, and pardon the breath, that's the problem with the headset. I got a big nose, and I breathe through my nose a lot. So, I think that pretty much sums it up. So hopefully you guys, you noticed how different it probably sounded. I'm on direct out of the rack right now. So the last thing I wanted to mention is the final stage. Once you get things kind of going and you're kind of happy with the way things are, go to a web SDR. If you can find a Kiwi web SDR that you can hit, from your home QTH, absolutely do it to it, because those are the best. They give you the most control, very similar front ends to like Sun, Apache Labs, Flex, any of those, and they give you full control. True AGCT, superb front end, depending on, of course, it depends on the receiving antenna, but if you can find one, check your audio through that. Worth their weight in gold. It'll tell you what's going on truly from a receive station standpoint. All right, guys, I'm out of here. I think that rounds pretty much rounds it out. Have a good day. Hopefully I got this right. I'm going to check it before I upload it. 73K1GMM.